As far as last night's homework, I want to spend a good deal going over this. I really would rather you grade somebody else's like we did before, but I'm not going to get into all that where we take them up and everything. So grade yours, preferably in a different color, like you are grading someone else's. So like really look for things that are wrong, things that are missing. So I want you to take the time to go through this more than just a regular homework.
You understand?
I think I'm going to skip around when I answer these because it seemed like some of you had issue type things with some of them and not others. So are some of you having issues with the graph for 3?
We did 1, 2, and 4.
So did y'all have issues with 1? Oh, mine is numbered different then. Okay, so the one that's number 4 is a manufacturer of high resolution. Is that right? Okay, sorry. The ones in front of me are just different numbers. All right, so I want to start with that one just because some people are, or I saw that some people are having some issues with that. But I want to talk about like the whole problem in detail, and we'll end up getting to the graph part. So reading through the problem itself, manufacturer of high resolution video terminals must control the tension on the mesh of fine wires that lie behind the surface of the viewing screen. Too much tension will tear the mesh and too little will allow wrinkles. The tension is measured by an electronic device with the output readings in millivolts. Some variation is inherent in the production process. Careful study has shown that when the process is operating properly, the standard deviation of the tension readings is 42 millivolts. Here are the tension readings from a simple random sample of 20 screens from a single day's production. I know that I don't have you write this out separate, but what would our sample be? The 20 screens that were selected? What could have been selected? So specific to that day, so you need to make sure that you are aware that it is just talking about specific to that day. So my state, what does it start with? So we want to estimate I have to decide if this problem's talking about means or proportions. We haven't talked about means or proportions yet, so that part should be obvious. But how do I know that this problem's talking about means? It says the word means. So just like before, we shouldn't have issues with that. So we're dealing with mean. So we want to estimate what's the variable that we're estimating? Mu, which is the true. And then in context, I do not have the right problem in front of me. I'm not going to write out all this, but I have it written as tension of the mesh of the fine wires that lies behind the surface of the viewing screen for this manufacturer on this day. I'm going to write tension of the mesh and then ... so that I'm not just writing it on board. But I want to be very clear that it is on this day. Because our population is always the ones who could have been selected. The ones that could have been selected are the ones that were just that day. And then how does it end? With 90% confidence. I did have somebody talk about this, somebody was taking their test last week and was asking something about this. If you have something really long, like tension of the mesh of the wires that lies behind the surface of the viewing screen for this manufacturer, and you want to reference it a lot, and you don't want to write that out every time, what do you think you could do? Just the way we assign a variable to something, we can do that with like an abbreviation too. Just like up at the top, be like, let this stand for this. So anytime you want to do that, you technically can. I usually don't make a big point about it until we feel good about the material that we're doing, but I think y'all are at that point now. So anytime you have long wording, you want to shorthand it and reference that shorthanded it, and that's absolutely fine. All right, so that's all we have for state. For plan, what's our first part of plan? Method. So again, method isn't very helpful right now because it's the only one we've done. How many samples am I taking? One. So it is a one sample. And I'm going slower than I usually would. What are my two options here? Z or T. We haven't talked about T yet. We're going to get there today. What word comes right after that? Why does it say interval? Because what are we doing? A confidence interval. That's what that stands for. And then we're specifically doing one for means and not proportions.
Are we ever gonna do like examples?
We go through means, proportions, then we go to, I can't remember what order we do it. We end up going to two sample for both, and then we end up going to a test instead of the interval for both. So now we gotta check our conditions. Sometimes I write check conditions, sometimes I don't. Like you're checking your conditions whether you write that's what you're doing or not. What is the first condition that we check? I always have people that get this wrong for no reason, essentially. What does this problem actually state? This problem literally says SRS, right? And I have people on other problems that say stated SRS when it says random. Can I do that? Does random mean SRS? No, this is more specific. So don't write that it stated that it's a simple random sample if it doesn't literally state that it's a simple random sample. So use wording from the problem here. But what do I actually need to see there? Random what? As opposed to random assignment. Part of why you need that is random selection means I randomly select from a larger population. So thinking back to chapter 4, what is our reason for randomization? We're thinking about it like that. That's actually the assignment one. So why do I randomly pick from your big group? What can I do with the answer that I get from your group? Say louder.
You can say from all possible.
Let's say I'm trying not to give too much. You generalize it back to that whole population. So we randomly select to be able to generalize it back to the whole population. The random assignment is the eliminate bias part. So random, what is my next one? All right, so again, talking more than I normally would on this. Looking at easy options here, what would our easy option be? It was stated. Does the problem state that it's normal? No. What would our second easy option be? Central limit theorem. Does central limit theorem apply? No. So you only go to this third one if the first two do not apply. So if the first one of the first two apply, you go with those. If not, you have to go to this one. So we have to do what? We end up dealing with stuff later to where we have histograms of different things. So this seems very vague that it's the histogram of values, but that's actually really important. If you just draw a histogram or write histogram and don't tell me what it's the histogram of, I will count off for that. So let's everybody have a calculator out, and because I want to address this once in detail and then not have to address it again. It's been a while since we've done this. And go ahead and type those numbers into a list. I know that some of you, when you're doing homework, are going a little bit quicker. I get that. If you're typing out a list like this in your calculator for a test, take 20 seconds to go back and check your numbers and make sure you typed in the right thing. See if I can do this to make it work. All right, so you've got it in a list. You're on a second stat plot. You are making a histogram of whatever list it was in. What button do you push if you graph it and you know you graphed it and you don't see it? Zoom 9. So like mine right now looks like that. Well, something's wrong, so I just hit zoom 9. And when I hit zoom 9, it's going to look like that. So I can use this as is, and I'm fine with that. Right now, if I go to window, I wonder if it'll do this. Oh, goodness. What's up with that? Right now, it says it has my min, my max. My min is 233.5. My cursor was on there when I did, I guess, screenshot. My X scale is what would change. So right now, they're setting it to where the class width is 28.22. So I usually pick that number and just go with something close, whether I'm thinking about it or not. So I'm just going to type in 30 and hit graph again. And all of a sudden mine looks like this. Well, I didn't change much there. And I like this one better than I like this one. I think it's worth it to take the time to do this, but you don't have to. So the other good thing about this is these numbers, when I did this way, my class width, my first class was 233.5 to 261.72, and I've got a lot of decimals to write. Here, I might even change that to make it even easier on myself. If I changed it to 30, I might change the minimum to just 233 so I don't have to deal with decimals. So now when I'm graphing, my first group is 233 to 263, and I'm just adding 30 each time. That's easier on me for graphing too, which is another reason why I like this. So you can manipulate your graph to make it look better if you're concerned with something like this one out here. Now, what we're generally concerned with at this point is is it so terrible that using the green sheet would mean absolutely nothing to it? So if we have data that is like, we've got a whole bunch out here. And we've got like a couple points that are just really way out here. If one of those were included, it would throw off everything. So something like really exaggerated, we probably would not want to use a normal distribution. But the one that we have here isn't terrible. That's still pretty symmetrical. Yeah, we've got a little bit of a gap, but nothing serious. This one looks even better and is easier to graph. So I would choose to take the time to do that, but that is up to you. So questions on how to do what I just did or why? Yeah.
If it's like definitely skewed, do we just solve the problem? Like, it's not normal.
If it's really terrible with really bad outliers, you would stop. But like I've said before, if I give you 6 questions on AP exam, one of them's not going to be like stop halfway. So it would be like, why couldn't I use this one for that kind of problem is how they would do it. So technically to answer your question, yes. But if we do a problem, probably not.
So you're not gonna like, give us any other stuff.
I'm not going to give you one. I'm going to do it like the AP exam would. And I would ask you like, let's start this graph, check the normal condition. Does it apply and why not? And instead of just asking you to do a 4-step. So I'd like ask it in pieces. Any other questions with this? Yeah.
Do we have to like tell you that we
No.
manipulate?
No. Mm-mm. And not manipulating it is absolutely fine. So whatever you plug in as your numbers here, like you have numbers on your number line. So on a test, I should be able to see your numbers, have the numbers in my calculator, and look at your first number and your second number and change mine to match yours to see if yours is right. It's like I won't have to go in and like redo everything. That's the whole point of it. But I think it is worthwhile to use that, if nothing else, to not have to write down all the decimals. Other questions with this? All right. So we were what, in the middle plan? So that gets us to our normal. Wonder if I could just copy it over. That would be nice. All right, so pretending I just drew this and all that other stuff isn't out there. Mine would have been, I think, 230 through 33, 263, 30 through, no wait, what was it about 30? Yeah, so 323. So what else do I actually need on there? Frequency. And these are up to, I don't even remember what those were.
I think the highest is 7.
I'm not overly concerned with exactness here. So like this is kind of a sketch, but I want to see this. But these values in general are what? Tension. So I want to see your title, the histogram of values. You need to write values down there. And then, so off to the side, I need to say what I checked for. And I checked for what? You don't it doesn't have to technically, no, writing fairly symmetric is fine. But it doesn't technically have to be fairly symmetric, but it can't what? It can't be overly skewed with extreme outliers. So I literally, usually when I write descriptions like this, they are generic. But with these, I literally write the same thing every single time and just write that same generic statement every single time. Actually, I usually split it and do it as 2. But you don't have to get more specific with this. We're basically not checking, is it so good that it looks good? We're checking, is it so bad that I can't use it? So we just say, no, it's not so bad, I can't use it, so we're good. And what do I need that's not up there yet? we can use normal approximation.
Would you prefer us to do like the either the gross metrical and no stream outliers or the no skew?
Did I use one sometime or something?
Yeah.
Did I say something else one time?
Yes.
It doesn't really matter. But see, the reason I would stick to this one because, it can be, sometimes it would be fairly symmetrical and sometimes it wouldn't. But it's always gonna be checking that and then you don't have to worry about situational. Which one did I use that I did fairly symmetrical? My example problem that I did during class. I didn't mention that in my process. Yeah, I would choose to go with that one with this no strong skew. Alright, I'm still in plan with my next condition. And what do I check in my independent condition? And what is 10% condition? Which one do I know? Lowercase n, so I'm basically saying, so n is 7, is that right?
That was 20.
I want to pick up the rest of 3. So there are at least 200. Now this, I always have people mess up on. Problem specific, there are at least 200 what? So be specific to that day because that was our population. Your wording's probably gonna be different. Screens tested for tension by this manufacturer on this day. So make sure that whatever your population there is matches the one that you said in state. If you miss one of them, like if this one you didn't say on this day when you said it in state, like some people are gonna forget to do that, but then you say it differently in independent, I'm gonna grade once for what you answered in state. I'm gonna answer independent that it matches state. So like if you get it wrong, match your wrong answer, so you don't get cut off twice for it. So just stay consistent. All right, questions for state and plan. All right, those should be the same other than the normal one. All right, so do, this one we actually found numbers, so our X bar was 306.32. Sigma, it gave us 42. N was 20. Confidence level was 90%. And somebody asked me about drawing these. You don't have to draw these out every single time. You're going to memorize them really quick. What do you get as your Z for 90%? We're actually going to end up using 1.645, but I'll show you why today. Because that one's exactly in between, isn't it?
Yeah.
So I don't care which one you chose right now. If you chose that one or 1.645, I would probably recommend 645. But that won't be an issue after tomorrow. All right, so my equation is X bar plus or minus what? Times So this is 306.32 plus or minus 1.645 or whatever you wrote there times 42 over square root 20, which gives us a lower bound 290. Does that sound right? And it might be different depending on 1.645 or 1.65. And 321.816. And then so I'm just gonna read the conclude. So we are 90% confident that mu, the true mean tension of the mesh of the wires lie behind the surface of the viewing machine, however you wrote that, on this given day will fall between this, what do you need to have the side of this number? Will fall between this what? Have your units with your MV for millivolts and 300, this one and that one millivolts.